All right, guys. Notes 8, general sinusoid graphs, hashtag math life. So before we officially begin the new stuff, we have some questions that might give you guys issues, maybe, maybe not. So it's these questions here. And so it says here, cotangent of 38 degrees. So how would you guys do this? If you have a CAES calculator or TI Inspire, you can just push the cotangent button, but you don't. So remember that cotangent is the reciprocal of tangent, so you can say 1 over tan of 38 degrees, and that will give you your answer. So I take my calculator, and I go, and I'm going to show you two ways. So I go 1 divided by, make sure you're in degree mode. So it says radian here, so push mode, and then turn the radian to a degree if it's not already. There we go. So now it's degree mode. 1 divided by, was it 38 degrees? So 1 divided by tan 38, push enter, and there's your answer. There's another way to do it. You can also do this. There's the reciprocal button. You see that x to the negative 1? That's reciprocal. So you could also do this. Tan 38, close it, and then push this little button. So that means reciprocal. It doesn't mean inverse. It means reciprocal. And then you just push enter, and look at that. Same thing. Cool, right? So now you guys are getting a lot faster. 1.27, what was the other two? 99? All right, so cotangent of 140 degrees. I'm going to go 1 divided by tan of 140. And then I push enter. So let's see, how can I do it? I can push tan of 140, and I can just push the little reciprocal button. Now, before I push enter, is it going to be positive or negative? Negative, because 140 degrees is in quadrant 2, and in quadrant 2, tan is y divided by x, or cotangent, right? X divided by y. X divided by y, and in quadrant 2, x divided by y is negative. Enter, and look at that. So the negative should not surprise you guys. Negative 1.1917. You don't have to do it like that. You can do 1 divided by tan of 140, and it's the same thing, guys. See? Negative 1.191, 192. I'm going to round it. 1.192. Negative 1.192. All right. Secant of 238 degrees. So secants are reciprocal of which one? Cosine. So I either put cosine 238. 238 degrees is in quadrant what? Quadrant 3. And in quadrant 3, cosine is negative, so secant will be negative. So there it is. It's negative. Of course, you don't have to do that little negative 1. You can just do 1 divided by cosine of 238, and you get the same answer. And there it is, negative 1.887. Negative 1.887. Are we still okay? All right, secant to 53 degrees. That's a reciprocal of cosine again. So I'm going to put cosine 53. Push a little negative 1. It's going to be positive because everything in quadrant 1 is positive. 1.6616. I keep doing that. 1.6616. Cosecant of negative 179. What quadrant is that? Negative 179 degrees. It's not quadrant 2. It's quadrant... Oh man, not everyone at the same time. It's quadrant 3 because you're going clockwise. Start at the positive horizontal x-axis. You go towards quadrant 4, and you're in quadrant 3, and you don't quite reach the negative x-axis. So it's in quadrant 3. So it should be, it's a reciprocal of sine, guys. So it's going to be negative. So I'm going to write 1 divided by sine of negative 179. And I push enter, and you get that number. You could also have done sine of negative 179 and push a little reciprocal button, and you would have gotten the same thing. Negative 57.2986 or 2987. Negative 57.2987 rounded. And then cosecant of 180 is the reciprocal of sine. 1 divided by sine 180. Do you remember what sine of 180 is? Sine of 180 is 0. So can you divide by 0? So this is going to be what? Start with the letter U. Undefined. Cool or not cool, guys? All right, cool. All right, properties of sinusoidal waves. So before we even start, you are being bombarded by waves all the time. All the time. Right now, you have sun rays. Right now, you have radio waves coming through you. If you turn on the radio, you're gonna be able to hear it. So you have a wave coming through here. You have your Wi-Fi signals. Those are all waves. Sound waves hitting you. The light waves hitting you. And then later on, guys, maybe not right now, but in the future, we're gonna find out with your generation. We're gonna find out if these phones. Every time you put a phone to your head, it's a wave going right through you, right? You know the frequency that's coming through this phone. These are all waves. Every time you use a microwave, it's in the name, microwave. It's a wave. That's a very dangerous wave. Don't put your head in there because they'll. Okay, don't be doing stuff like that. Anyways, those are all waves, guys. They're all over the place. So let's do properties of waves. I'm gonna try and draw a wave. I'm gonna try. I'm not the best here, but let's see. It's okay. It's not my best wave, but let me draw another one because I don't feel like it's that good. Let's see. Yeah, that one's not bad. I think that one's a little better. Okay, there's my wave. It's supposed to be symmetric about that black line there. That black line is usually called, it's called one of two names. It's usually called either the midline or sinusoidal axis. Relax, sinusoidal just means wave. Properties of sinusoidal waves. Are we okay? When you were in Algebra 2 or maybe Algebra 1, you studied convex and all that stuff, concave up, concave down. Well, this is known up here as concave down, upside down bowl. And this is known as concave up. You have points of inflection. All these are points of inflection. They're always at your midline for a sinusoidal wave. Points of inflection. What does a point of inflection mean? It's a point where concavity changes. Are we still okay? Okay. A period or a whole cycle, peak to peak, it does not have to be peak to peak. This is a period. We could also say one complete cycle. Let's see what else. Oh, the amplitude. The amplitude, take this burnt orange here. The distance from the peak to the midline is called amplitude. You could also say that's the same as the distance from the minimum to the midline. That's also amplitude. I have maximums and minimums. Sorry about the sound effects. That line is a max line. You do not go higher than that line. And that line is your min line. You do not go lower than that line. Let's see. It pretty much covered everything except frequency. Frequency is the reciprocal of period. If the period is in seconds, if period is in seconds, comma, frequency unit is hertz. Hz. Don't hurts me. Okay, that was dumb. Yeah, it is. It's physics. Yeah. Because physics is pretty much just math. How do we feel, guys? Okay. All right, here we go. Don't freak out. This is the same as when you were in Algebra 1 and Algebra 2. We just went down the alphabet. This on the inside is called an argument in the parenthesis. Every function has to have some type. Okay, well, anyways, let's just start from the beginning. The A stands for amplitude, which is just your vertical stretch or compress. The B is your horizontal stretch or compress. The C is your shift, your horizontal shift. And the D is a vertical shift. Just like when you were in Algebra 2. Now we're just dealing with waves. Sometimes your horizontal shift is called a phase displacement. It's okay, don't freak out. Cool? And then the midline or the D, the vertical shift, sometimes that's called your sinusoidal axis or your midline. So yeah, don't freak out. We already talked about period. We said that no, we didn't. Well, we kind of did. Period to figure this out is 360 divided by your B. So that means that the B, to figure that out, is 360 divided by period. Or if you're in radians, B is equal to 2 pi divided by period. And there's a reason for the 360 and the 2 pi, guys. 360 degrees is the period of your parent function. So, okay, and hopefully you remember f of ax. Remember that told you that your horizontal stretch or compress was whatever the reciprocal of 1 over a is? No? Okay, then don't worry about it. We'll do a lesson on that pretty soon. Okay, how do we feel right now? All right, we're about to do our first graph. We're about to do our first sketch. What do you guys prefer, degrees or radians? Yeah, one for radians. Everyone else, radians or degrees? You want me to tell you what your other classes said? The other classes said degrees, but I can do radians if you guys want me to. What do you guys want? It doesn't matter to me. Okay, go ahead and draw that grid. I'm going to say that's negative 90 degrees. And I'm going to try to make it consistent. I'm going to go by 90. I'm going to say this is a max of 1 up there. And I'm going to say here's my min of negative 1. Now we're doing sin x. I'm going to go slow. What is sine of 0 degrees? This is a safe space, guys. Tell me what sine of 0 degrees is. Is it 1 or is it 0? It's 0. What is sine of 90 degrees? 1. Yeah, don't be scared, guys. Just say it. What is sine of 180 degrees? Is it -1? Is it 0? What do you guys think? What is it? 0. What is sine of 270 degrees? -1. What is sine of 360 degrees? 0 again. And then I got one more point way over here. What is sine of -90 degrees? That's the same as sine of 270. So it's going to be -1. Not everyone at the same time. Are we okay so far? All right. Wherever you have a maximum, put an upside down bowl, but make it aim towards these points of inflection. Chop, what do you mean? Like this. See? Wherever you have a minimum, put a bowl, but make them stretch like if you're going towards those point of inflections. All right? And then connect. Try to make those points right on the x-axis. Try to make those points of inflection where it changes concavity. Doesn't have to be perfect. And there's your first sketch. Yay! Feliz Navidad. Oh, sorry. It's not Christmas time yet. I can't wait till Christmas time. I can't wait till Halloween time. All right, make another grid. I'm going to do again max of 1, min of -1. I'm going to call this -90 degrees. Yes, Ochoa. Because in the unit circle, the maximum is 1, and the minimum is -1. Good question, miss. You know what I mean, right? By the maximum is 1 and the minimum is -1 in the unit circle?
Yes.
Okay. Because like cosine, the biggest cosine will ever be is 1. Every other number, square root of 2 over 2, square root of 3 over 2, those are all smaller than 1. Because the radius of the unit circle is 1, right? Okay. Now we're graphing cosine x, guys. We're going to go slow. What is cosine of 0? Hey, that's a nice calculator you got there, Delgado. Yeah, it's a pretty color. Yeah, sorry, guys. I saw pink. I was like, wow, that's pretty. Okay, what's cosine of 0, guys? Yeah, 1. What is cosine of 90 degrees? 0. What's cosine of 180? What is it? -1. What's cosine of 270? What is it? 0. What's cosine of 360? 1. And then, since I put the -90 here, what's cosine of -90? 0. Wherever you have maximums, upside down bowls, stretch it towards your points of inflection there. Wherever you have minimums, bowls. And then try to connect it, make it look, see, concave down, and then I pass that, concave up. Concave up, concave down. And there it is. Not the best drawing, but that's fine. How do you feel? Not bad, right? Are we okay so far, guys? All right. Here we go. So it says, suppose that a sinusoid has a period of 12 degrees per cycle. So that means my period is 12 degrees. Amplitude of 7 units. So amplitude of 7. Phase displacement of -4. Phase displacement is the same as the horizontal shift. So the C is -4 degrees. with respect to the parent cosine function. So that's what we're gonna focus on today, guys. And a sinusoidal axis of 5 units below the x-axis. So that's your D, because that's sinusoidal axis. That's the D. -5. It says below the x-axis. Sketch this graph. Okay. Let's draw a grid first. Let's see. I'm going to draw the x-axis first. And let me put the x-axis a little higher. There's a reason why I drew it this way, guys. I'm going to go slow. Are we still okay so far? All right. First thing I'm going to do is I'm going to draw my sinusoidal axis. That's the midline. So the sinusoidal axis is your midline. So it says 5 units below. So I'm going to say -5 is like right here. -5. And then my amplitude is 7. So that means from the -5, I'm going to go 7 up, and that's my max line. And I'm from -5, I'm going to go 7 down, and that's my min line. So from -5, I go 7 up. So if I go 7 up, 5, 6, 7, I'm going to be at 2. Try to make it the same gap. And I'm going to go 7 down. 5, 6, 7, 8, 9, 10, 11, 12. Is that -12? So do that. I'm going to stretch this guy just a little more. Are we still okay? Okay. Notice they say the parent cosine function. So guys, look at the cosine function. I want you to notice something. And this is the one we're going to focus on today. Notice the cosine function has a max right on the y-axis. Do you guys notice that? So I am moving that. It says phase displacement -4. So that means I'm moving that peak 4 degrees to the left. So I'm going to say that -4 is like, -4 is like right here. And I'm going to put a point right there. So put a point at -4, 2. Does everyone see why I put a point at -4, 2, guys? Be honest. No? Okay. You see this? Thank you for being honest, miss. You see how cosine x has a peak right at the x-axis, right on the y-axis? So it's imagine, so I'm going to come over here so you can see it visually better. So imagine, Ochoa, that this graph here, that I could just drag it 4 units to the left. If I drag it 4 units to the left, that peak is going to be at the -4. Correct. All right. So now, notice that the period is 12. Remember that the period is how fast or how long it takes to do one complete cycle. So I'm going to be at another max 12 degrees to the right of that. Yes or no? So where do I have another max? At what? Not everyone at the same time, guys. At 8. Good job. How'd you get 8? Yeah, you move 12 spots. -4 plus 12 is 8. Good job, miss. Put a point at 8, 2. Move another 12 from 8. Move another 12 from 8. You're going to be at... What's 12 plus 8? You're going to be at 20. Make sure to put a little degree symbol because we're working with degrees. You're going to be at 20 degrees. I think I can put one more. I think I can fit one more max. So let's see. Let me fit one more max. I'm fitting one more max in here. Another 12 from that. I believe that's 32 degrees. How do we feel? Nothing crazy, right? Okay, so catch up to here. You should have 4 maximums. Are we okay so far? All right, and no yawning, that's a demerit. Okay, here we go. The next minimum, now I'm going to graph the minimums. It's all about symmetry, guys. It's all about symmetry. In between the maximums, I have a minimum, right smack in the middle of between the max. So let's focus on the 8 and 20 because I think this is easier to see than dealing with negative numbers. What's in the middle between 8 and 20? Well, I know that this gap is 12 degrees. So I just go 6 degrees from the 8 to the right or 6 degrees from the 20 to the left. It doesn't matter. If I go 6 degrees to the right from the 8 or 6 degrees to the left from the 20, I'm smack right there in the middle. The middle is more like right there. Let me see. Can I erase? There we go. Right there. And then that middle is 14 degrees. Does everyone see how I got the 14? And at the 14 degrees, I have a minimum. So go all the way to the lowest point and put a point. So at 14, go to negative 12 and put a point. Do you guys see that? Now I'm going to go another 12 from the 14. 14 plus 12, 24, 26. So at 26, another point. Chav, how do you know where it's at? Well, it repeats every 12 degrees. Bam. 26. It's all symmetric. Plus 20 plus 6, 26. 32 minus 6, 26. All right, let's see. Let's go to this one way over here. In between the negative 4 and the 8. So at 2. I'm going to say 2 is like right here. Bam. Okay. So you should have, there's your 3 minimums. Okay, I think we're winning. All right, don't plot it yet because it would be a really bad sketch if we were to plot it right now or we were to try to curve it. It's all about symmetry again. All right. In the middle, between 20 and 26, in the middle between high and low, is a point of inflection. And that point of inflection is at the midline. Cool or not cool? So, in the middle between 20 and 26, that gap is 6. So that means I'm going to be at the 3 mark, 3 away. So right, bam, that's not the point of inflection. Right, bam, at 23 degrees, I have a point at the midline. So 23, put a point at the midline, which I already forgot the number, negative 5, I think. At 29 degrees, 26, 19, 29, yep. At 29 degrees, put a point at the midline. Do the same thing, keep doing that. In the middle between 14 and 20, put a point at the midline. In the middle between 8 and 14, a point at the midline. In the middle between 8 and 2, so at 5, a point at the midline. I'll designate here 5 degrees. In the middle between negative 4 and 2, so that means at negative 1. Put a point at the midline. All right, so now we're ready to do our sketch. Everywhere you have a maximum, upside down bowl, aim it towards the points of inflection. Anywhere you have a minimum, a bowl, aim it towards your points of inflection. And then connect them. And voila, look at that. Beautiful. Beautiful. You're beautiful. Okay, I'll stop. I was trying to do Christina Aguilera, but I don't have her voice. Yeah. She also sings a song, it's called Beautiful, as evidenced by the song that I just tried to sing. But, yeah. Sorry. Sorry, YouTube. No. All right, how do we feel? All right, so a lot of kids think that drawing is the hard part, so that's what we're going to do the next time. A lot of kids think that giving the equation is the easy part. Maybe the first time you do it, you're like, but after you do this 2-3 times, which we're going to do it 3 times today, after you do it 3 times, you guys seem to get the hang of it, and it becomes really simple. Hey, miss. So check it out. Find the equation for the graph you sketched. Okay, we're going to deal with cosine. So start getting in the habit of just doing this. Y equals A, cosine, open parenthesis, B, open parenthesis, X minus C, close, close, plus D. I just went down the alphabet. A, B, C, D. That's all you're going to plug in. You're going to plug in A, B, C, D. Those need numbers. And check it out. I already kind of have those numbers here on the side. I have all of them but B. Cool or not cool? Well, how do I get the B? Well, if you scroll up to your notes, it tells me right here that I get the B. If I'm in degrees, I get the B by doing 360 divided by period. So I'm going to come back and I'm going to write B equals 360 degrees divided by the period, which is, what was the period on this one? 12 degrees. The B does not have a degree symbol. I guess you can think about it as like degree canceling out. It's just a scale factor or dilation there. 1 over 12 is the real scale factor. Take your calculator, go 360 divided by 12. I mean, if you don't need a calculator, you don't need it. But if you need it, you need it. It's 30. So I come back. So here we go. I'm going to do this. I'm going to write y equals, what's my amplitude? 7 cosine, open parenthesis. What's the B? 30, open another parenthesis. X minus a negative 4. So that turns it into a what? Positive. 4, it's a degree, so put a degree symbol. 4 degrees. Close it twice. Close, close. And then what's the midline? And there it is. How do we feel? Okay. All right. Real quick, guys. Check this to make sure that it's correct. How do you check it? Does everyone have a calculator? Go to your calculator. Push y equals. You should not have anything in there. If you do, just clear it. Push that equation that you just got. Can you guys hook me up with it again? I already forgot it. 7. Was it 7? Cosine 30. Open parenthesis again. X plus 4, I think. Then close, close. And then what was it? Minus what? Minus 5. Make sure it's a minus and not a times. So don't push graph yet. I'm going to show you how to do that. So everyone catch up to here. Does everyone have that much? Okay. All right, here we go. I'm going to go slow, guys. I'm going to go real slow. Push the button that says window. Maybe yours already has something already in it because of previous. X min means the minimum X. X max means the maximum X. XSCL means X scale. Like how often do you want me to put a little hash mark? Y min means the smallest value for Y. Y max means the biggest value for Y. And Y scale means how often do I put a hash mark. So let's look at my graph. So notice the smallest X value is -4. I want to go a little bit more to the left of that because I want to see a little more. So I'm going to put like -6. So -6, enter. X max, well, I come over here. The biggest I have is 32. So want to go a little bit to the right of that. So I'm going to put 35. 35. X scale, well, let's see. I usually went, we can go by 5 or by 6. Let's go by 6. Y min, the smallest Y value I have is -12, so let's go a little bit below that. -15. So -15. And then Y max, the biggest Y value I have is 2, so let's go a little bit above that, so like 5. And I'll leave this here. Y scale, maybe go by 5. That way we don't have so many hash marks. Okay, there's my window. Does your window look like this? Don't worry about X resolution and delta X. Your delta X might be different than mine. That's fine. But leave the X res as 1. All right, here we go. Push graph. Mine's way faster than yours. If you want to see the midline, see, there it is. If you want to see the midline, I go back to Y equals. It was -5, so I go to Y2, and I put -5, enter, and I push graph again, and there it is. Cool or not cool? All right, don't worry, we're gonna check it. But Chav, I see a wave. But how do I know that this is the exact wave? Well, push the trace button. I know that I have a max at -4. So push -4, trace -4, and push enter. At -4, do I have a max at 2? Yep. Don't worry, we'll do it again. Trace, I know that at -1, I'm at the midline. -1, enter. And there it is, -5 at the midline. Cool, right? I know that I have a min. Where's my min? My min's at 2. So if I once you push trace once, you don't have to push trace again. You can just push a number 2 now. 2, enter. And look at that, 2, -12. Do you guys see how we're doing this? Okay. In case you're wondering, Chav, when am I ever going to use a sinusoid and do all this stuff with a calculator? Guys, it's the skills that you're going to take forever. You guys are the future nurses. You guys are the future doctors. What if instead of a sinusoid, this was a heartbeat, and you were the one that was in charge of calibrating that little screen so that you can see the heartbeat? See, so it's the skills guy that's messing with this technology to make sure that you can fix a window so you can see stuff. Cool or not cool? Okay, you guys are doing fabulous. Let's keep going. All right, look at this one. So go turn the page. Don't worry, we're almost done, guys. We just have 2 questions left, and not drawing is just getting an equation is easy for you guys. It says, for the sinusoid below, give the period, frequency, amplitude, phase displacement, and sinusoidal axis location. Write a particular equation for the sinusoid. Okay, so right off the bat, here's what I want you to do. Y equals A, and all we know right now is cosine. So cosine, open parenthesis, B, open parenthesis, X minus C, close, plus D. That's all you know. Let's see, which one's the easiest to get? Probably the midline? Okay. I think the midline is the easiest to get. How do you get the middle? It's the name, midline. It's in the middle between the highest and the lowest. How do you get the middle of anything? You add and divide by 2. That's how you get the middle of anything, guys. So that's exactly what I'm going to do. I'm going to add my high, I'm going to add my low, and I'm going to divide it by 2. My highest Y value is 56. My lowest Y value is -38. And whatever that is, I'm going to divide by 2. 56, 38, 38, 48, 58, 56. So 18 divided by 2, 9. I do it in pieces. You can put 58 plus -38 divided by 2. But be careful. When you do it in the calculator, guys, do it like this. When you do it in the calculator, if you do it like this, 58 plus -36. If you do this, the calculator is dumb. It's going to think you're doing 36 divided by 2. So either use parentheses, you go 58 plus a -38, close it, divide that by 2. Either use parentheses like, why did I get 10? Oh, because I put 58. 56, sorry guys. 56 plus -38 and divided by 2. You either use parentheses, there it is, my 9, or use the alpha feature. Alpha Y equals, push enter. I think there's also, okay, if you guys have the new calculators, you can also put, well, I'll show you. 56 plus -38, and then on the bottom put a 2, and then look, you'll get your 9. You can also push second link. Oh, I guess mine doesn't do it, but on yours it might. Second link. Okay, I've seen it on the new calculator, there's a little fraction feature, but I guess mine doesn't have the new operating system. All right, so there it is. Are we cool, guys? All right. Now, I think what's easiest to get is the amplitude. So let me show you where that 9 is at. My scale here, that's a 50. 10, 20, 30, 40, 50. So this is going by 10. 10, 20, 30, 40, 50. So that means the 9 is probably right. Well, it is. Not probably. It is. It's right below that 10 here. I can't draw. I can't draw straight. Okay, I tried my best. So there it is. There's the midline. That's not perfect, but you know it's close enough. So the amplitude is the distance from the peak to the midline. That's your amplitude. Or you don't have to use that. Like Chop, I want to use the mins all the time. Well, then fine. The distance from the midline to the min. I always think it's easier to work with positive numbers. So I'm just going to do 56 minus 9. So the A is 56 minus 9. 56, 46, 47. Are we okay, guys? Okay, there's my amplitude. So now I need to get my phase shift. If I'm using cosine, I think the C is the easiest to get now. If I'm using cosine, remember, this happens at a peak. Happens at a peak for cosine. So where's my first peak at? And actually, you can use 23 if you wanted to, but you usually want to use your first peak. Where's your first peak at? At what x value? At 3. So 3 degrees to the right. For cosine, parentheses for cosine. It's different for sine, guys. For sine, you have to use a point of inflection going up. We'll talk about that the next class session. And the last thing, I already got my A, I don't have my B. Okay, how do I get the B? Well, first you got to get your period. So there's so many ways to do it. I have a peak at 3, and I have another peak at 23. The period is how long it takes to do one cycle. So how do I get the period? 23 degrees minus 3 degrees. So the period is 20 degrees. So the B is 360 degrees divided by 20 degrees. Is that 18? Because 2 goes into 36 18 times. 360 divided by 20. Yeah. 18. Are we okay so far? Okay, here we go. The only thing I am left with is, actually I got everything. A, B, C, D. I got everything, guys. Here we go. Here's my equation. Y equals, the amplitude is 47. Cosine, open parenthesis. The B is 18. Open another parenthesis. X minus 3 degrees, close, plus 9. And I would check, I would not just take my word for it, I would check this, guys. So type this into y1. So here's my equation. I'm going to clear that. Hook me up with the equation again. 47 cosine 18, and then with it x minus 3. Close, and then plus 9. All right, and then I'm going to put 9 here, and don't push graph yet. Click on window. Let's see. The smallest I have is 0, 1, 2, 3, negative 3. I'm going to make my window look exactly like this. This is going by 1. I know that because 1, 2, 3, 4, 5. See, that's because it says 5 right here. So I know that the x-axis is going by 1. And these are degrees. I should have put, I did it through Desmos, so I wasn't able to put a degree symbol in there, but those are degrees. So here we go. I'm going to put negative 1, 2, 3, negative 3. So negative 3. And then x max, let's see, 25, 26, 27, 27. And then x scale by 1. Y min, let's see, I go all the way, these are by 10, 10, 20, 30, 40. Let's go 42. Negative 42. Negative 42. Y max, let's see, 50, 60, 62. And then y scale by 10. And there it is, push graph. All right. Bless you. Oh, bless you squared. That was cough, okay. Let's see, guys, if we get these exact values. At 3, I better be at 56. Push the trace button. Trace, 3. Enter. Does it say 56? Yes. Push the 13 and see if you get negative 38. 13, enter. Do I get negative 38? And then one more, 23, and see if you get 56. 23, enter. And look at that. Cool or not cool? Okay. We got one more, guys, and then we're done. All right, so let's read this, and we're going to go slow. It says, the figure below shows a quarter cycle. What does a quarter cycle mean? 1/4 or 25%. Write that down. 1/4 or 25%. Write a particular equation and check it by plotting it on your graphing calculator. Okay, relax. It's not that bad. This is 25% of your graph, guys. So from 25% of your graph, you go midline to high or midline to low. Like this is what I'm trying to say is this. That's your midline. Chav, how did you know that was your midline right off the bat? Because 25% of a cycle is going to be either midline to high or midline to low. Or high to midline or, so this obviously looks like a point of inflection. This looks like a low. Because I can already see it turning. So it looks like my amplitude is 5. Do you guys see that? The difference between 8 and 3 is 5. So I'm going to go another 5 up. 8, 9, 10, 11, 12, 13. That's 13. I look at this gap. 17, 18, 19, 20, 21, 22, 23, 24. That's 7 degrees. 7 degrees for a quarter. So that means the period is 7 degrees times 4. So the period is 28 degrees. If you don't like that, relax. I'll show you another way. You can graph what this is in pieces. So if I go another 7 degrees to the left, I'm in midline, so I'm drawing to the left. From the midline, I'm going to go to a max, and I'm going to try to keep this grid the same. So I'm going to say that's 10 degrees because I just subtracted 7 for the point, and here it is. If I go another 7 degrees, that's a 3 degrees, and it's going to be right at the midline. So there it is. Let's see, from the 24 degrees, I'm going to add 7. So I'm going to be at 31. And I'm going to be at the midline, from the low to the mid. About another 7. I'm going to be at 38. And that's going to be at a high. And there it is. If you did not like how I got the period the first time, you could do this, peak to peak. You could also say, or 38 degrees minus 10 degrees, which also gets you 28 degrees. Cool or not cool? Yes, Ochoa. Yeah, that's a good question. Why did I multiply by 4? Because this is 25% of a quarter. This is 25% of my period. So if it's 25%, if I multiply by 4, I get my whole period. But you don't have to do that if you don't like it. You could rebel against me and say, I don't like that, Chop. Then just fill it in, and then just do peak to peak. You know what I mean? Okay. All right, here we go, guys. I got everything I need. So I'm gonna write y equals a cosine, because that's all we know. B parenthesis x minus c close plus d. What's the amplitude? Not everyone at the same time, guys. What's the amplitude? Yeah, 5. The b. I get the b by doing 360 divided by period, 28. I don't think this one's going to be a nice number, but we want to keep it perfect, so just turn it into a fraction like this. Chav, what are you talking about? 360 divided by 28, and I get a number that keeps going forever like this. So to turn that into a fraction, you just push math, fraction, enter. 90 over 7. It's just reduced. 90 over 7. The C. You can actually put 38 if you wanted to, but usually you want to pick the one that's closest to the y-axis. What's your shift? Where's your peak at? Where's it at, guys? Yeah, say it out loud. 10 degrees. Say it out loud, guys. I can't hear you guys. Where's your midline? 8. All right, there it is. You got everything. Y equals 5. Cosine, open parenthesis. 90 over 7, open another parenthesis. X minus 10 degrees, close, close, plus 8. I'm going to go ahead and type that into the calculator. I want to see that it works. I'm going to clear this, 5 cosine. I'm going to use the fraction feature. You don't have to. You can just push 90 over 7, but I like to see it nice and clean. 90 over 7. And then open x minus 10. Close, close. And then plus 8. I'm going to put 8 here on y2 because that's my midline. And I'm just going to change my window to look like that one. Window. Let's see. I'm going to say 0. X for x min, 0. For x max, I'm going to say 40. For x scale, I'm going to go by 5. Y min, I'm going to say 0. Y max, I'm going to say 15. Y scale, let's go by 2. Graph. All right, let's see if I did it right, guys. I know that at 3, I better be at the midline at 8. So I push the trace button. I push 3, I push enter. And yep, I'm at 8. I know that at 10, I have a max. So I push trace, I push 10, I push enter, and there it is, at a max, 13. I know that at 17, I better be at the mid. 17, enter. Yep, I'm at the midline, or sinusoidal axis, 8. And at 24, I better be at the low. 24. And there it is, 3. I just remembered something. I don't think I answered the frequency question. Was the figure quote right or particular? Wasn't there an example that said, give me the frequency? Was it this one? Yeah, I didn't. Man. Well, it's okay, because it's just the reciprocal of that. Frequency. 1 over 20. That's fine. Okay, that's it. What do you guys think? Not bad, right? All right, guys, you guys did fabulous. Let's take care of the assignment. There is a delta, but it's only like the class did it in 3 minutes, so it's over midline and amplitude. So don't even worry about that. Do that last because it's so simple. And you have until tomorrow anyways, but do it whenever you get a chance. And then just take care of that assignment. You can work on it as a group. And that's it, guys. We're done.